So what we're going to be talking about here, which is something that we learned from the lab that we just did, is that we learned that the Q of a hot substance is equal to the Q of the cold substance, right? Because we had our two kind of cups full of water, and when we mixed them, we saw that any energy here that was lost was gained by the energy over here. So our energy of the hot substance, aka the energy lost, is equal to the energy that was gained by the cold substance. So we have our two examples from the lab the other day. And so what that means, again, if we look to number 10, I believe it is, in that same lab, what we can do is we can find out that our MCAT for the hot substance is equal to our MCAT for the cold substance. Because if we know that each of these Q's equal MCAT, like the equation that we've been using, if Q equals Q, then MCAT equals MCAT. So the energy lost from the hot equals the energy that was gained from our cold. So we have MCAT equals MCAT. Now what that means here is that we have two substances that we have to focus on. In our lab, we saw that both of those substances were H2O, hot H2O, cold H2O. So we have two substances, which means we have two different masses, we have two different specific heats, and we have two different changes in temperature. Now, the tricky part here is when we're looking at the change in temperature, because what we noticed is that we'll just make up some data. We'll say that our hot water started at 48 degrees Celsius, and if we kind of put it on a scale here, all right, if our hot substance was at 48 and our cold substance was somewhere around, we'll say 23 degrees, we know that our final temperature was somewhere right in the middle, all right? And so what we can see is maybe our final temperature was somewhere around 35.5 degrees Celsius, all right? And we'll look to calculate that over here like what we did in lab. So using this information, we can come over here and look at the mathematical side to show why this is happening. So in lab again, we said that our total amount of our substance that we can use is 150 milliliters, because that's the max amount that those cups could hold. And we know that 1 milliliter of water equals 1 gram of water, right? So I saw a lot of people were doing, if we come back here, we're doing about 60 milliliters maybe of their hot water, and then 60 milliliters of their cold water. So again, we'll use that data to help us out here. So if we go ahead and we fill out the side that is hot, all right, what we can do is we can fill in our 60 milliliters, which we got here from up here, and we know that 1 gram equals 1 milliliter, so we have 60 grams. We know our specific heat for water is 1 calorie per gram degree Celsius, and we can see that our change in temperature, all right, over here was 12.5. All right, so our change in temperature was 12.5. All right, so what we're getting at here is that this side here has to be equal here, because again, law of conservation of energy states that that we cannot create or destroy energy, just like with matter, except in here, all right, we're looking at the energy again from that was lost from the hot substance is being transferred into cold, because we know again heat transfers from hot to cold. All right, and so if we look at our mass of our cold substance, all right, again it's 60 grams. We're still dealing with water, so we have 1 calorie per gram degree Celsius for our specific heat, and then we have our change in temperature again, which was 12.5. So what we see here with ideal conditions, ideal data, we see that our masses of our hot and cold substance are equal, our specific heats are equal, and our changes in temperature are equal. So this again is ideal data. Probably did not occur, because when you were doing your data, what might have happened is that while you were transferring your hot substance into your cup, you lost some heat and it escaped into the surroundings, and so we didn't see this true ideal data. So now we can take this idea of energy loss equals energy gained, heat lost equals heat gained, right? MCAT equals MCAT. And now we can do a problem on the next page. So we're on page 10, and if you look on page 10, you can see that we have exactly what we just found out. Our heat lost is equal to the heat gained. Our MCAT is equal to MCAT. And again, the energy that's lost is from the hot substance. The energy that's energy gained is from the cold substance. So I'm going to get a different color marker so that we can make our lives a little bit easier in differentiating between energy lost and energy gained. So on page 10, we're looking at number 1, and we can see that the question says determine the mass of 90-degree water, that's needed to raise the temperature of a 15,000 milliliter tub of water at 27 degrees to 70 degrees, right? So if we go ahead and set up, again, going back over to this, we set up our temperatures, right? Because that helps us figure out that this is the temperature of our cold substance, starting temperature, and this is the starting temperature of our hot substance, and this is what we got as a result. This was our final temperature for both our hot and our cold. So we come over here, and we know we're determining the mass of 90-degree water. So if we look and set up our little temperature thermometer-ish thing, all right, we know we're starting at 90 for our hot substance because it's the hottest temperature out of the 3 that we get. We have 27 as our cold substance, and because we have 70 is in between these two, we know that that is going to be the final temperature of our example here. All right, so again, we're determining the mass of our hot water, all right, which is needed to raise the temperature of 15,000 milliliters, which again, we know 15,000 milliliters equals 15,000 grams, according to our 1 milliliter equals 1 gram conversion. So if we go ahead and set this up, we can look at our MCAT of our hot is equal to the MCAT of our cold. Again, our energy lost by hot is gained by our cold substance. Energy lost, heat lost equals heat gained. So we can go ahead and start to fill this in. So we don't know the mass of our hot substance, so we go ahead and keep that as our variable. We know again that we're dealing with water still in both situations, right? Both of our substances, the energy lost, energy gain, we're dealing with water. So we keep our C value at 1. And then our change in temperature here for this hot substance, if we come over here and we look at the difference between our starting temperature and our middle temperature, we can determine that we have a 20-degree difference. So our change in temperature for the hot substance is 20 degrees. All right, so that's that side of the equation. On the other side of the equation, we know that our mass is 15,000 grams, and this should be in blue because it's talking about the cold substance. So we have a 15,000 gram substance here. We know we're still dealing with water, and so we have a value of 1.0 grams. And then our change in temperature again, we can come back here and look at the difference between our starting temperature for the cold and our final temperature, which comes out to be 43 degrees. So that is our change in temperature that we'll plug in over here. All right, so this is where we get back to the rearranging of an equation. We need to know how to rearrange an equation in order to solve for this. And so because we're multiplying our mass by our C and delta T value, we're going to do the opposite function. So for multiplying, the opposite function is dividing. So we can divide by 1 and 20, which we know that we don't really need to worry about the 1 because multiplying anything by 1 is that same value. So we multiply that on both sides. And this is our equation, right? These cancel out. And so our new equation, if we were to rewrite it, is our mass that we're trying to find is equal to the MCAT of water, of cold water, which we just wrote right here, divided by 20. Again, we can get rid of that 1 because multiplying 20 by 1 is still 20. So when we end up doing that, we can go ahead and find that our value here, you plug it into the calculator, and the mass of this hot substance is 32,250 grams of water. And so again, the main idea behind this and what we're trying to figure out is in science, in general, when we're looking at the energy that's lost by one substance, we're going to see that it's gained by the other. And so in this case, we see 32,250 grams of water, cold water, was needed to see this temperature change. Again, heat lost equals heat gained.